Welcome back. We'll now do a problem that I think will bring everything together. And frankly, this is a fairly difficult problem. And if you get this problem, you are on your way to becoming a physics master. So let's get started with this problem. So we have this setup here, where we have a wall and a floor. And we have a wire or rope attached to the wall here. And then it goes around this pulley. And this pulley, for the sake of this problem, let's just say this pulley is somehow supported in the vertical direction so it doesn't fall to the ground. And then this wire goes back around the pulley and then it's attached to this 10 kilogram mass. And in this case, and this is the first time we're dealing with a pulley that actually has mass, this pulley has a mass of 5 kilograms. And even more, the pulley isn't even fixed. We are going to pull on the pulley. And we are going to pull on the pulley with a force. Let me get my pen tool set up because this is an exciting problem. We will pull on the pulley with a force of, let me make it clean lines because let's say we will pull on this pulley with a force of 150 newtons. Somehow it's being compelled to go in that direction with a force of 150 newtons. Even more, the coefficient, so this pulley is somehow up in the air and it's being supported there. So we're not going to, we're not going to assume that it falls or something like that. It's only being pulled in the rightward direction. So don't worry about the up and down motion of it. But the problem also tells us that the coefficient of friction between this block and the ground, the coefficient of friction is 0.4. So I could write that here. Let's see, coefficient of friction is equal to 0.4. So the question is, what happens here? What happens? So in any physics problem, before you break into the numbers, I think it's always a good idea to just get a conceptual sense of what it should look like, what you would think would happen. So someone's pulling on this pulley, and this wire is staying fixed. So what's going to happen? They're going to pull on this pulley. The pulley is going to go more and more to the right. As the pulley goes more and more to the right, this top length of wire will get longer, and the only way that that top length of wire gets longer is if this bottom length of wire will get shorter. So the pulley will be moved to the right, and at the same time, this 10 kilogram mass will get closer and closer to the pulley. And if you think about it, whatever the velocity of the pulley to the right, the velocity of this 10 kilogram mass will be twice that. Why is that? Well, let's say this pulley moves 1 inch to the right, right? If the pulley moves 1 inch to the right, then this length of rope right here will get 1 inch longer, right? Because the pulley went 1 inch to the right. And this length of rope, because the rope is of a constant length, we're assuming it doesn't stretch or anything, will get 1 inch shorter. So not only did the pulley move 1 inch to the right, but this rope down here got 1 inch shorter. So this block would have moved 2 inches to the right. Hopefully that makes sense. So if whatever the velocity is of this pulley, this mass's velocity will be twice as much. So similarly, whatever the acceleration of this pulley to the right, the acceleration of this block will be twice as much. And why is that? Well, acceleration is just change in velocity. And so if my velocity has doubled and this guy's velocity is double that, his change in velocity will be double that. I don't know if I just said a circular statement, but hopefully that makes sense. Just think about what happens. If this guy moves an inch, this length of cord will also get shorter by an inch. So the pulley will move an inch, and then this guy will get closer to a pulley, so he would have moved 2 inches. So his velocity and acceleration are double that of the pulley. And that's an important thing to realize. So with that out of the way, let's solve the problem. That really is kind of the big thing you should realize about this problem. So let's with that tucked away in the back of our mind, let's do the problem. So what are all the forces acting on this block right here? Well, we know it's going to be moving towards the right. It's actually going to be moving towards the right twice as fast as the pulley. So if it's moving to the right, which direction is the force of friction acting in? Well, the force of friction is always a spoiler. It's always going in the opposite direction. So you have the force of the friction going backwards. Right? And what is that force of friction? Well, it's going to be the weight of this mass, this weight of this block, times the coefficient of friction, right? Because the weight comes down, and that's equal to the normal force, and the normal force is equal to the weight. You know all of this already. So the force of friction is going to be equal to the coefficient of friction, 0.4, times the weight of this block. And what's the weight of this block? It's going to be 10 kilograms, which is the mass, times the acceleration of gravity. So that's 9.8, so it's 98 newtons. I'm skipping some steps here because I think things like, what's the weight of a 10 kilogram mass block, I think are hopefully a bit of second nature to you now. So it's 0.4 times 0.98 newtons. And if we get the calculator out, that is 0.4 times it's 0.4 times 98 equals 39.2 newtons. Equals 39.2 newtons. So that's the force of friction going backwards on this mass. Well, what's compelling the block to go to the right? Well, it's this wire, this rope, right? So that's the tension in this rope is pulling on this block. So we call that T. Right? So what are the net forces acting on this block? And let's say, what are the net forces to the right? Well, it's T, right, which is the force of tension of this rope. I could have done it along the rope, but I just did it here. T is the force of tension. I'll draw it. Actually, I will draw it along the rope, just so you know. It's the rope that's exerting this force of tension. So the force of tension minus the force of friction, which we figured out to be 39.2 newtons, is equal to the net force on this object, right? Is equal to the net force, at least in the left, right, or horizontal direction on this object. And that's going to be equal to its mass times its acceleration, right? The net forces on an object are equal to its mass times acceleration. That's Newton's second law. So what's its mass? It's 10. And if we knew the acceleration, we wouldn't have to do this problem. So we don't know what it is, so let's just say it's A. So 10 times acceleration is A. So these are the net forces acting on this mass. And we don't know what A is. So let's put that aside a little bit. Maybe I'll put a little square around it. And let's figure out what's happening to the pulley itself. So this is interesting. The pulley has this mysterious force, maybe it's my hand, pulling at 150 newtons to the right. And what's pulling it to the left? Well, in both cases, this wire is pulling it to the left. And the tension throughout a wire is constant, right? Unless, the material changes or something. Well, even then it shouldn't change. So the tension through the wire is constant. And in both cases, the wire is pulling back on this pulley. So if the tension here is T going in this direction, the tension in this direction is T. And the tension in this direction is also T. And we'll learn more about pulleys when we start doing mechanical advantage and things, and why, how it doubles the force needed, but the distance goes in half, and all of these type of things. And we'll do that later. But all you have to realize is that the tension through the wire is constant, and this pulley essentially has the wire pulling on it twice, right? Once on top and once on the bottom. So what are the net forces acting on this pulley? Well, you have 150 newtons to the right, 150 newtons to the right, and then it has a force of tension twice pulling to the left, right? Because the wire wraps around it. So minus 2t. And that equals the mass times the acceleration of this pulley. So that's the mass, which is 5 kilograms, times the acceleration of pulley, times the acceleration, the acceleration of pulley. And this one up here was the acceleration of the block. And what was the first thing that we discovered about this problem? That the acceleration of the pulley is equal to half the acceleration of the block, or that the acceleration of the block is 2 times the acceleration of the pulley. Either way, that was the first thing that I went off about, how the pulley moves an inch, and at the same time this bottom part of the rope gets short, or wire gets shorter by an inch, so this thing moves twice as fast, right? So let's substitute here for the acceleration of the block. So the acceleration of the pulley is 1/2 times the acceleration of the block. So let's substitute. So we get 150 newtons minus 2 times the tension of the wire is equal to 5 times, instead of the acceleration of the pulley, it's 1/2 the acceleration of the block. 1/2 the acceleration of the block, of this block here. And now let's try to solve. So, well, we don't want to solve yet. Well, we have to somehow substitute for what the tension of the wire is. So let's do that. And actually, I'm getting flustered because I realize I only have 10 seconds left. So I will see you in the next video.